So we're going to do it both ways. I'm going to sort of make a column here so that I can do the examples next to each other. So we're going to have y equals x squared plus 1, and then x minus 3. Okay? And on this left side, so I'm just going to draw a little line, okay? We are going to simplify first. Okay? So we're going to simplify. That means actually multiply out. So I'm going to do the FOIL here. So y equals first, outer, inner, last. And most of the questions are find y prime. Okay, find the derivative. Okay, so I get 3x squared minus 3. Oh, sorry. Thank you, because I missed a squared. Okay. 6x plus 1. Oh, okay. That wasn't too bad. Okay, right. So we have two choices. Simplify first or last. This time, because I have two things multiplied together, I can do the product rule. Okay? You have to figure out what you can see, right? What rules can you use? Because I have a product, so I'm just going to go f is x squared plus 1, and g is x minus 3. Right, so I have the first part and the second part. I'll zoom a little. Okay, so we have to do the derivatives. Derivative of g is just 1. Because I see a product, so the first thing I'm going to do is find y prime. So I'm going to set up the product rule. So here's my start. Multiply, multiply. All right, y prime is the first times the derivative of the second, product for plus, the second times the derivative of the first. Okay, there's my rule. And then simplify. Okay, so first I found the derivative. Second, I am simplifying. Okay, so simplify means PEMDAS. Parentheses, exponents, multiply, divide, add, subtract. X squared plus 1 minus 2x squared minus 6x plus. Okay. Combine your like terms. Prime equals same answer. It doesn't really matter which order you do it in. You're going to get the same answer. So it's kind of up to you. Which way do you prefer? Simplify first, simplify last. It's pretty similar in terms of the arithmetic, okay? So it just sort of depends. Neither one is wrong. It depends upon what you see in the problem and how you choose to answer it. Okay, so we're going to look at a second example. Now this was just a polynomial. See how I had positive integer exponents? I'm going to start mixing in maybe a negative exponent, maybe a fraction exponent. Okay? Here we go. Y equals x plus 3, 4x cubed minus 3x to the negative 1. Okay, it's still in power format. Okay, see that? Each of these pieces looks like a polynomial. Okay, so we're going to do it both ways. I'm going to do the simplify first. That's what I'm going to choose to do. Okay, so simplify. Okay, y equals. All right, here comes my FOIL. First, outer, inner, last. All right, be careful with your exponent rules. Okay, so when I do x times negative 3x to the negative 1, I get x to the first. You add exponents when you multiply. You add exponents when you multiply. So when I do the last, that ends up being just negative 3x to the 0. Okay, because you add the exponents when you multiply. First, outer, okay, x to the 0 is nothing. It's a 1. This is a 1. Okay, so it's negative 3. First, outer, inner, last, minus 9x to the negative 1. Okay. Is this statement in power format? Yeah. That means you can do the power rule. Find y prime. 16x cubed, 0, plus 36x squared, okay, so drop my power, subtract 1, and for good practice, I'm going to take this negative exponent and I'm just going to put it back into the reciprocal format. Okay, there's my result. All right, two choices, right? Simplify first, simplify last. So we're going to do the same problem, but we're going to do the simplification after we do the rule. So I notice that I have a product. I have a product because I'm multiplying these two things together. Okay, so find y prime. That's the question. Notice we're just switching the order. Okay, so if I find y prime first, I have two pieces. So we have f and we have g. Okay, you've practiced your product rule. See if you can't fill out where each of these pieces go. Okay, there's my little placeholders. Fill it out. And then we'll do the simplification together. Okay, you can do the product rule. you what. Okay, good, I see it. Okay, so I'm going to start filling in my pieces. So I get 12x plus 3x to the negative 2. Okay. The first times the derivative of the second. Yes, thank you. Okay, plus the second times the derivative of the first. And multiply, right? So now that you have the rule, now you simplify. All right, lots of distributing here. Let's see if I can do it correctly. Y prime equals 12x cubed plus 3x to the negative 1, right? Because I'm adding my exponents. Okay, plus 36x squared plus 9x to the negative 2. I'm just going to have to distribute here, okay? Plus 4x cubed, and conveniently they line up. Okay, that's just because I didn't have room to multiply it all out there, so I just did 2 rows. And combine your like terms, yes.
If you just wrote 3 over x, would that also work?
Oh, sure, that's fine. So as I combine my like terms, I notice those 2 pieces are the same. So I get y prime equals 16x cubed. Okay, I'm going to go in order. So now I see the squared. Same variable, same exponent. Okay. Next thing I notice is that these 2 pieces both have x to the negative 1, but they're actually opposites. So that makes a 0. And then the last part, okay, right there. Now, as I rewrite this, I'm going to move it to the denominator, right? You should get the same result. That is the whole point. It's still the derivative. They should be the same. So if you get stuck one way, try the other way, okay? Simplifying first tends to have a little bit less multiplication because the product rule automatically has 2 things that you're multiplying. But here, I just have one set of multiplication to do. So usually there is less work on the simplify front. Okay? Now, we're going to do a problem with radicals and reciprocals. Okay, so that'll be our last example. And then I will tell you why you actually have to have the product rule. Because so far you're like, why can't I just simplify it? I mean, that's my question. Why would I do the product rule if this other column is so much easier? I wouldn't. I would do the easier choice. Okay, but there is a reason you have to have the product rule. Okay, here we go. Number 3. Okay, so we got to add some radicals in here. Okay. Y equals cube root of x multiply 2x minus 1 over x. Okay, there's my problem. Last problem for today. Simplify first. Okay. Distribute. Oh, okay. Right, this is how do I multiply it? All right, well, I'm going to multiply it 2 different ways to show you, but the first thing I'm going to do is literally just write the 2 things next to each other, right? 2x times cube root of x minus cube root of x over x. You're like, well, that doesn't look very simple. I still have like all these x's together. All right, well, combine these two x's. When you multiply x's, you add the exponents. So we end up with 2x to the 4/3. It's still exponent rules, but instead of being all positive integers, which you just add in your head because it's like intuitive, you actually have to remember that you're supposed to add the exponents. So it's 1/3 and 1. 1/3 and 1 is 4/3. I'll do a little extra line in here. I'm just adding work, I'm not wrong. So you add the exponents, so we end up with 2x to the 4/3. All right, now I have this part, which is x to the 1/3 over x to the 1. When you divide variables, you subtract the exponent. So that's 1/3 minus 1, which is negative 2/3. Because it's like minusing 3/3 or adding 3/3. Yes. Okay, so we have this, x to the negative 2/3. So right now, all I have is y equals. Okay. Find y prime. That's the question. Find y prime. Y prime equals. Okay, so we get 8/3 x to the 1/3. Well, you've got to know your power rule with those fractions and those negatives. Okay. Drop the power, so that becomes positive 2/3. Subtract 1. Okay, now the last thing I'm going to do is cube root x. Right, I'm going to put it back. Right, because my answer started with radicals, so I'm going to write my answer with radicals. Okay, plus 2/3 power root. Cube root x to the 5th. And you do not need to rationalize or simplify the radical. We're just positive exponents. That's what we're writing it with. Okay, so I know it's not necessarily the placing of the product rule that you need help with. Okay, it's probably all those kind of exponent rules and simplifying that you maybe didn't get a lot of practice of last year or the year before, just because of when you were in the building and when you weren't. There is a choice, okay, I'm just going to show you. What if you think of your power format, okay? What if you think of your power format before you start doing anything, just to sort of see what you've got. Okay, so 2x to the 1st, right? I'm showing you multiple things to see what makes the most sense to you, okay? This way, kind of long, but maybe that's what you recognize. So here, I started by doing power format. I'm not doing the derivative yet. Okay, I'm not doing the derivative. I'm just writing it in power format. What if we distribute from here? Because when it looks like a polynomial, you might remember the exponent rules better. So here we get x2. Oh, when I multiply, I'm supposed to add my exponents. Maybe you just see the adding as a little more intuitive because of the format that we wrote it in. Okay, let's do the next distributing. Minus x 1/3 minus 1, right? Because we're multiplying here, so we add the exponents. Oh, we still end up with the same answer, okay? Okay, f prime, right? This is the derivative. It's still the same, it's just a slightly different simplification, okay? Where I chose to do the power format first. I'm not going to do the product rule. Why would you do the product rule with so many different formats? You've got a radical, a polynomial, and a rational. Why would you do the product rule? Just multiply it out. Less multiplication to begin with. Okay. In your product rule homework, okay, you have the table questions, you have the product rule questions. I want you to try to simplify one of the 5 product rules, okay? Just one of them, which is going to work on your exponent rules and combining your terms correctly. I just want one of them. And then there's a few questions that actually look like what we just did, where you have to do the simplification because it's going to require you to simplify for the answer. All right? Now, before I cut you loose to do your homework, okay, why do we have the product rule? Okay, what if I do this? Why do we have to do the product rule? Okay, why? You're like, it seemed like that first column was pretty much the simpler route. Okay, what if you can't simplify? What if you can't simplify? What if foiling is not an option? Okay, like, but what does it look like if foiling is not an option? All right, what if I say f of x times x cubed? Can you simplify f of x times x cubed? I don't know how to multiply them. You can't simplify. When you can't simplify, the product rule is the only choice. Okay? So you have to know the product rule. There are some times when you cannot avoid it. All right, what if, okay, what if I actually mix types of functions, okay? And when I say mix them, I mean things that don't have, like, power format, okay? Power format, trig. That is as simple as that product gets. You cannot simplify this product, means you would have to do the product rule. Now, in this class, we mostly focus on power format. So we do negative exponents, fraction exponents, and integer exponents. We don't really do the trig, but that's why you have product rule. Okay? Because sometimes there are products you cannot simplify. What if I said e to the x? Oh, e. Where the x is the variable. Okay? Times 7x to the negative 2. That is a product that you cannot simplify. Okay? Now, when I highlight, these are the pieces that we learn how to simplify. Okay? We don't do this one and we don't do this one. All right? Let's see, what else do we need a product rule for? Oh, there's a couple other things, but I'll say them later. All right, guys. Here is your choice for working right now. There is a review worksheet that I'm going to pass out to you. Okay, looks like this. Next week, this has to be done by the end of next Monday. Okay, we will spend time doing some questions like this on Monday. All right, but if you are already caught up on your homework, you can certainly start this now. Okay. So open up your homework, your Delta Math. That's what we're going to work on right now. All right. Here we go. If you maxed out on some of your attempts, I will open those up for you in just a minute. So when it says any format, you don't have to simplify. You're just literally filling in the blanks and entering it. Yeah. So this is, so if you're caught up on your Delta Math, this is the worksheet that needs to be turned in by the end of Monday. Okay, Monday we'll do a few examples of some of the words that we see in this worksheet. Okay, so when it says any format, you're just fill in the pieces, present. Okay. Good? Yeah. Okay. This is for when you finish your product. Yep. Yep. Yeah.
Which one should I do next?
Yeah, that one. Start there.
But I only have one try.
You actually get multiple tries to it. I'll reset it if you don't get it. So you still get 2 chances to get it right.
Okay.
Yeah. See, this is what we just did. So just take your time. Work on the rules. And I'll check it for you.
Okay, thanks.
Slowly, Okay, I think everyone's got their worksheet. Yeah, I think it says simplify first.
Yes.
So for most of the time, these are the ones where you would have to use the product rule. If you don't have to, I wouldn't.
So more, how would I multiply that?
Okay, so this would be 16x to the 5th over x to the 4th. And then you could simplify it.
So you would multiply this?
No, you're fine, you're fine. That would just be x to the negative. No, that's, you're good, keep going.
Wait, why is it x to the 4?
Because it's on the bottom.
Oh, so just over.
Does that make sense?
Yeah.
Okay, so you guys saw the multiplication in different formats. You chose power format and multiply. You just distributed,
Yeah.
okay? Simplify, rewrite in power format, because you're about to do the derivative, so you gotta do that. Okay? Yours is already in power format.
So am I done?
No, you gotta do the derivative. Yeah, look around. Any marker you find, you can use.
Thank you.
Four pointer. So if you're done, yeah. Yep.
Okay, so now I need to do this.
Yes. Now, it might have you write 4 minus 16 over x to the 5th. Oh, yeah, right. power rule, right?
Oh, so then
Oh, 4 times 4, you forgot 16, that's what it was. 4 times 4.
Oh.
That's, okay, yes, that's it. So now it's 16 plus 16 over x to the 5th.
That's it?
Yeah.
Do those two cancel out? Is that what-
Are you multiplying them? No, you're adding them.
Okay,
So no, they
that's
don't.
fine. I just
Yeah.
wanted to make
Yeah.
certain.
Okay, so the only thing I'm gonna say here, make sure you, divide it to its square in both places, because we don't know quotient. So just do that first. Yes, kind of like the simplify we just talked about, simplify, so you don't have to use the other rules. Okay, so you've got 10 and you have f of x. So that's like our first example where you have to use the product rule. So yeah, 10. What's it? What is 10?
How are you going so quickly?
Okay, except that here, this is not just minus. Yeah. Yeah. But yeah, that's the right idea. Yeah, so in any form means you don't have to simplify. Now, in this particular case, I mean, it's kind of like taking it both ways, since there's so many terms, but because it says any form, you're not simplifying, you're just literally filling out. And then on one of them, and there's 5, on one of them, try to simplify.
Okay.
That's it, yep. Okay. Yes. Oh, okay, I will reset that one. Yes. I don't know. Do you type it in and try?